Hi guys, this is video 2-7 to be watched Thursday, October 6th, the weekend of that. This is your long weekend. I hope that you're enjoying it. And the homework that corresponds to this video lesson, well, first of all, I should say, this is page 14 in the video packet that we're on. And the supplies that you'll need for this video lesson are a graphing calculator and also the transparency, if you still have it. If you don't, the transparency thing that represents a tangent line. If you don't have it, just watch what I do, but it'd be very effective if you did have it. The homework that corresponds to this video is on page 11 in your homework packet, and it's only going to be number 1, just one example. And guys, right next to this I have written with added directions. So right now I'd like you to take your video pack or your homework packet and turn to page 11 in it. So here it is. I'm going to add some directions. So this is page 11 in your homework packet. And so video 2-7 homework. And what I would like you to do is the directions that say write the equation of the tangent line to the graph of the function below at the indicated point. I'd like you to make that part A. Okay, so like I did here. So that's going to be part A of the directions. And part B, and just write this down for now, but it will make sense later. Graph the function, or f of x, with the tangent line. Zoom box around the point of tangency. That's what POT stands for. And sketch your screen. Okay, so please add in those directions. You might want to pause the video so that you can write them down. So we're adding to the homework directions. But still, it is just the first problem on page 11. Okay, guys, so before starting the video, I took the liberty of filling in these things because this is review. Parallel lines have equal slopes. Perpendicular lines have negative reciprocal slopes. And the point slope formula, which we're going to be using a lot from now on, is y minus y1 equals mx minus x1. That will allow you to write the equation of any line you want, given the slope of it and just one point on it. Okay, so here is the example, guys. There's 2 parts to this. So we're going to let f of x equal the equation, or equal 4x to the third minus 3x minus 1. And part A, we're going to find an equation of the tangent line to the graph of f at x equals 2. All right, now I just want us, guys, anytime you're doing any problem in this course, you want to try to visualize what's going on. And if you cannot visualize what's going on, then you should get your graphing calculator and just try to visualize the problem. Okay, so I have my graphing calculator. And let me graph the function that I'm working with. I'm just going to try to get a handle on what I'm being asked to do here. So I go 4x to the third minus 3x minus 1. Oh, crap. I put it all in the exponent. Okay, so to the third, I got to hit the right arrow, minus 3x minus 1. Okay? And let's graph this just in a standard window. So a 10 by 10 window, if you go down to zoom, zoom and then 6, that'll give you a standard window, which is 10 by 10. Okay, so that's the graph we're working with, classic cubic. And I'm going to take my, okay, so at the x value 2, the input value 2, which is about right there. Okay, the point that corresponds to the graph is up there. And what I want to do is I know this looks kind of silly, but I want to imagine the tangent line, which is pretty steep. The tangent line at that point, I'm trying to write the equation of this line here, of that tangent line. Well, guys, if we want to write the equation of this tangent line, we just need to know 2 things about it. Its slope, number 1, and number 2, just one point on it. And guys, the point on it that we're going to use is what's called the point of tangency. It's the point that is shared by the tangent line and the graph. It's the point where the tangent line touches the graph. All right, so now back into the problem. So if I just know the slope of this tangent line and one point on it, then I can use this formula to write its equation. All right. Well, what's another name for the slope of the tangent line the derivative. So what I'm going to do is I'm going to take f of x and I'm going to find its derivative. So I go f prime of x. And remember, guys, you don't have to use those limit definitions anymore. We have the power rule. So the derivative is 12x squared minus 3. Okay? And they're asking for the equation of the tangent line to the graph of f at the x value 2. So if I want the slope of the tangent line at the x value 2, I just plug 2 into the derivative, and I end up with 45. Okay, so that's going to be going in for m. Now, I need a point on my line. If I'm going to use this formula here, I also need to know a point that is on my line, and I'm going to use the point of tangency, okay, which in the homework directions I called POT. All right, but the point of tangency, well, we already know its x coordinate is 2. And then for its y coordinate, I've got to take 2 and plug it back into the original function. Okay, so 2 comma f of 2. And I already did this. If you plug 2 into f of x, the original equation, we get 25 for the output, so 225. All right, so now I'm ready to write the equation of this tangent line. So I'm using the point slope formula. Y minus the y coordinate equals the slope m times x minus the x coordinate. And guys, that's all that you have to do. You don't even have to solve for y, okay? This is a good enough answer for AP Calculus, all right? So that's the answer to A. Now, we actually are going to get y by itself because what I'm asking you to do on the homework, which is not in the directions here, but which I'm going to add to the directions so that you can see how I'd like you to do it in your homework, is, okay, so back to part B of the homework directions that we wrote in earlier. I'm going to graph the function with the tangent line and zoom box around the point of tangency, and then I'm going to sketch what I see on my screen. Okay, so I'm going to show you what I mean to what I added to the homework directions. Okay, so I already graphed the original function in a 10 by 10 window. Now I'm going to graph my tangent line. Okay, so I'm going to have to add 25 to both sides in order to get y by itself to do this. So I go down here, and so I have 45 parentheses, x minus 2 close parentheses plus 25, and I graph that. And there goes the tangent line, actually pretty similar to you know, what I tried to anticipate with my transparency earlier. It's very steep. Okay, now, but I want like a very nice picture of this. So I want to get in really close to the point of tangency, and I want to just see that tangent line like just touching the graph at that point of tangency. So what I'm going to do, and guys, this is, we're all going to have like different pictures for this part, but I know that my point of tangency is 225, all right? The highest that this, like I can see my x coordinate 2 right there, but the highest that my window is going is 10. So the first thing I'm going to do is I'm going to go to my window and I'm going to change the y max like to 50. Okay. And then I want to show you this really cool feature that I learned when I was at Broome Community College. It's called Zoom Box. I don't know, I showed the kids last year and they had not seen it before. But go to Zoom and then go to the very first one is Zoom Box. And then, where is it? Okay, so see that thing, that like blinky thing? I'm going to put a box. This is going to create a window for me that I'm going to zoom in on. Okay, like around my point of tangency. I know my point of tangency is like right about there. So this is going to be the upper left corner of my box. So I hit enter as soon as I have like the position that I want. And then I start going right. Okay, and then I go down, so that's going to be the upper right hand corner of my box, and then I go down. Okay, and then as soon as I'm done, as soon as I have the area that I want to zoom in on, I hit enter, and let's see how this looks. Okay. See, I wanted a prettier picture than that. Um, this is the tangent line is it's a very close match to the graph in this window. So I want to see like more of a I just want to see a prettier picture. So what I mean by that is I want to see more of the graph curved and more of the tangent line like just, kind of touching the graph once and then going on. So what I'm going to do is I'm just going to elongate my window. So I'm going to go to the window. And when I did zoom box, this was the window that was created by my box. And I'll just do my Y min. I'm just going to go 0 for my Y min. All right, and then I'm going to hit graph. Okay, that looks better. That looks more like a typical tangent line situation. Like you could see the graph curving here, and then there's a very, clear distinction between the tangent line and the graph down there. But I want to see more of a distinction even up here. And the tangent line and the graph are looking less and less distinct up here because the graph is cubic and it's growing pretty fast. Okay, so the rate of change is pretty steep, like the line, around these values. But let me go back to my window and I'm going to, maybe I'll just do like 50, I'll do 60. Yeah, I think that looks pretty good. Okay, so on your homework, what I would have you do, okay, so like you could see the point of tangency is like about right there. There's the tangent line, and there's the nice graph. Okay, so what I want you to do on the homework, even though it doesn't say on these directions, is I would want you just to sketch what you see. Okay, so I'm just sketching it. I see something like this when I look at my, this isn't even really, not doing a great job, but something like this. And then I take my ruler. I don't know. Just so I know that you are visualizing what's going on. You're able to visualize the situation here. Okay, guys, now part B. Find the coordinates of any points on the graph of f, our original function, where the tangent line is parallel to that line. Okay, so again, if you can't visualize what's going on here, go to your graphing calculator. All right, and feel free to use your transparency. I'm about to. All right, so I'm going to go back to y equals. I'm going to erase the tangent line at the x value 2. And I'm going to graph this function f of x along with the line, okay, that they're giving me, so x plus 12. I'm going to graph it in a standard window, so I'm going back to Zoom 6 or Zoom Standard. And I'm going to try to visualize what they're asking me. So there's a line, there's my graph. They want me to find a point on the graph of f of x where the tangent line would be parallel to this line, okay? And maybe there's more than one point, I don't know yet. So I'm going to take my transparency, and you might not feel the need to do this, but I think it'll be helpful. And I'm going to start off on top of the line, and then I'm just going to move it closer and closer to the line, keeping it parallel, having the same slope, okay, until I hit, a point of tangency on the graph, and looks like right about there, guys. Okay, so like right about there, I don't know, I'm looking at like maybe negative 0.5, something like that. A negative number like less than 1, and then its corresponding y coordinate. But then if I go through the graph and I keep my line parallel and I come out on the other side, it looks like I'm going to have another point of tangency over here that has a tangent line parallel to our given line. All right, so it looks like I'm going to get 2 x coordinates that have the slope of the tangent line is going to be the same as that, as the slope of that line too. Alrighty, I hope I'm articulating well. So here we go. So find the coordinates of any points on the graph of f where the tangent line is parallel to that line. So parallel lines have the same slope. Slope of the tangent line is the derivative. So, I'm going to go m equals f prime of x. All right. the slope of the tangent line is the derivative. They're the same exact thing. All right. Well, guys, what is the slope of this line? It is 1. So they want f prime of x. What do they want it to equal? They want it to equal 1. All right. If this situation were happening, then the slope of the tangent line, or the derivative, would be 1, meaning that it would be parallel to this line, which also has a slope of 1. Alrighty, so now I'm just going to carry down the 1. F prime of x, I already found it in the last problem. It's this. Okay, so I'm going to flip this, or I'm going to set it equal to 0. Or no, I don't need to do that. I can just go 12x squared equals 4. So x squared equals, I'm dividing both sides by 12, I get a third. Okay, so now I'm getting that x is plus or minus the square root of 1 over 3, okay? Which is pretty close to what I visualized on my graph. Now, they're not just asking for these x coordinates, they want the points on the graph, okay? Points on the graph. So I need to find the corresponding y coordinates for these points. Okay, so now, so I know that one of my points is radical 1/3, and I've got to find the corresponding y coordinate, and the other is negative that. Okay, well, I've already got, I'm going to use table ask here. Okay, so I need to plug these back into the original function. Okay, so I'm going to go back to y equals, I'll erase this line so it's not in my way. And then I'm going to go to my table. I'll go to table set. It is on ask. So now I'll go to the table. And there's some previous values in there. But I'm going to plug in radical 1 over 3, enter. And oh, it looks like I already practiced this earlier, so you could see some of the same values repeating. But so here's radical 1 over 3. If I go to the right, there's its corresponding y value. And if you highlight it, guys, the table itself will only show you like 3 decimal places, but if you move over to it and highlight it, down here you can see the longer decimal. And for AP Calculus, we want at least 4 decimal places. So I'm just going to copy down what I see on my calculator. Go ahead of me if you feel like you've got this. But the y coordinate that corresponds is, actually that doesn't seem right. Y equals, maybe it is. All right, go ahead of me, guys, if you've got this. Okay, I guess that's good. So negative 1.9623. 9623. Okay, and then do the same thing but with negative radical 1/3. I already did that, I think. And I got negative 0.0377. Okay, guys, I'm sorry that was maybe my longest lesson yet, but I really want you to be able to visualize what's going on. I could have just flown through that by just showing you the mechanics of it, but the visualization is very important, I've come to learn. Okay, I hope you really enjoy your weekend, guys, and I'll see you on Tuesday. Please email me if you have any questions at all. Okay, bye-bye.